Well, howdy there, spectacular humans. I hope you're having a good day. It's Miss Wait here to, kind of blow your mind with a little more geometry. So here's a warm-up for you. You're being asked to find the missing angle measure of a triangle. That's going to go back to what we talked about in the last video. And then also writing the converse of a statement should be in your notes a couple of pages back. So go ahead and get this warm-up done, and then come on back and we'll go over it together. Alrighty, so finding the missing angle measure of a triangle means that you know how much they total to. You have to know how much they add to in total so that you can find the one that's missing. Well, good news, you have a thing called the triangle sum theorem, and the triangle sum theorem says that all three interior angles of any triangle will sum to 180. Now we can write that as a mathematical expression. We can call this triangle A, B, C, and we can say that the measure of angle A plus the measure of angle B plus the measure of angle C always equals 180 degrees. And that's the usable equation we can draw out of that theorem. Now, you could do that. You could also just take 56, add it to 35, the measures of A and B, and then subtract that number from 180. That's okay. What I'm trying to do with translating the theorem to a usable equation is build good habits. So that's why we do it that way. So the measure of angle A is 56 degrees, and the measure of angle B is 35 degrees. And to that, you're going to add the measure of angle C, which all we know about it now is that we're calling it x, and that's going to equal 180. And now we've gone from theorem to usable equation to actual equation. Now we're going to add up 56 plus 35. 56 plus 35 is 91. And to that, we're going to add our x, and that's going to equal 180. Now subtracting 91 from both sides gives us that x equals 89. And there you go. So knowing that all three interior angles of any triangle sum to 180 made it so we could solve this problem, and that means that you understand what a theorem is trying to tell you to do. Now in the next one, we have written converses before, but not much, so I just kind of wanted to remind you, because we're going to be using it during this lesson just a little bit. When you want to write the converse, essentially what you're doing is reversing the order in which reversing the order of a statement. So you kind of leave the if and the then in the same place, but then you switch the other parts. This part gets switched with that part. And so if a triangle is isosceles, then two sides are of equal length, could be written as its converse, and that would be if two sides are of equal length, then the triangle is isosceles. Done. So that's how you write a converse. You leave the if and the then, and you switch the other two parts. And we're going to be doing that in just a bit. But now's a good time to update your notebook, write yourself some questions, a summary, get that new note page ready. Remember that your summaries are the answer to the essential question at the top of the page. And what you're doing is you're using your notes as evidence to summarize what's there and to answer that question for yourself. Come on back when you're ready. Your essential question today: what is the relationship between the sides and angles of isosceles triangles? The topic is the base angles theorem. Oh yes, another theorem. So we're going specific now. The last time we talked very broadly about all kinds of triangles and what was true about all triangles. Today we're narrowing it down to just isosceles triangles. So in order to do that, let's define isosceles triangles a little bit and make sure that we know about the names of its parts. Now I'm not going to be super specific and scientific with these, but you'll get the basic idea. An isosceles triangle is what you get when at least two sides of a triangle are congruent to one another. An isosceles triangle is a triangle with at least two congruent sides. As soon as you know which sides are congruent to one another, they'll be marked in some way. Those sides are called the legs of an isosceles triangle. The legs of an isosceles triangle will be the sides that are congruent. The sides that are congruent. And then the other side, the third side, the one that is potentially not congruent, is called the base. The side that is not congruent. I'm going to pause here for just a second and point out two technicalities. The first one is that when we're saying that the legs of an isosceles triangle are the ones that are congruent and the base is the one that's not, that's leaving out a type of isosceles triangle called equilateral triangles. Because notice that the definition of isosceles triangle says that it's a triangle with at least two congruent sides, opening us up to the fact that an equilateral triangle is also isosceles. So when we call two sides, the ones that are congruent, the legs, and the one that's not congruent, the base, we're assuming that we have two congruent sides and only two. So that's one thing. The second thing is that we have to be careful when we call the one side of a triangle the base, because in the English language we mean the base to always be at the bottom, and this is not going to be the case potentially with a isosceles triangle. In other words, that side is still called the base. It's not at the bottom, it's somewhere over there, but it's still called the base because the base is not defined by where it is. It's defined by the fact that it's the one side that's not congruent. So be careful. In this particular case, in this particular figure, the base is at the bottom, but it won't always be. Remember to look for the one that is not congruent. So then that brings up the types of angles that we have. The base angles are the angles that open up onto the legs. In other words, they are like across from the legs. The base angles are the angles across from the legs. And then that leaves one more angle to talk about. It's called the vertex angle. And notice where it's situated. It's across from the base. The angle across from the base. So as soon as you identify the legs and the base, you can find the base angles and the vertex angle. All right. So I'm going to ask you to do a little investigation. If we were in the classroom together, I like to do these little projects that make it so that you can see the geometry. But since we're not in the classroom, it's a little bit trickier. But here's how you can do it. You can go get a ruler and a piece of paper, and then on that paper, carefully draw an isosceles triangle. That's why you need the ruler, because you need two sides that are exactly the same length, and so you'll have to measure them. Then you're going to take the paper and you're going to fold that triangle so that the base angles of the triangle are right on top of each other. Now remember where the base angles are. They're the ones that are across from those congruent sides. And so for this triangle, you would fold it kind of like down that dotted line and bring the base angles right on top of each other. Now when you do that, you'll probably notice something significant if you can see both base angles through the paper. And then I want you to think about, what does this say about the base angles of an isosceles triangle? So go ahead and do that if you've got the tools to. If not, that's okay. We're going to do it together in just a second anyway. All right. So what I have here is an isosceles triangle. Now I haven't marked it, but these are the congruent sides here, which means that down here are the base angles, okay? I'm going to take this isosceles triangle and I'm going to quote unquote fold it and compare those two base angles. But I'm going to have to be clever because I can't really fold this screen. So what I'm going to do instead is I'm going to pick up this one and I'm just going to flip it. And then I'm going to bring it over here. So it's as if I have folded. And now I have one base angle on top of the other. And what do you notice? Hopefully what you notice is that they are exactly the same size. And this happened with this isosceles triangle. Likely you saw it with your isosceles triangle. And it turns out with every single isosceles triangle, the base angles will be congruent. And since it happens every time, we can write a theorem about it. The base angles theorem goes like this. In an isosceles triangle, the base angles are congruent. And this is great news, because as soon as you know that you have an isosceles triangle, you know something about the angles of that triangle. Specifically in triangle ABC, we see that it's marked with two congruent sides. That means it's isosceles. And so what we know, the base angles, or the angles that are across from those congruent sides, are congruent to one another. So we can take information that we know about sides and transfer it over to angles through this theorem. Now, we can write the base angles converse theorem by flipping these statements around. And here's how we can do it. If two angles of a triangle are congruent, then the triangle is isosceles. We just switched them, and that's also true. If two angles of a triangle are congruent, then the triangle is isosceles. And so just like in the second triangle ABC, notice that we have a couple of angles that are marked congruent. We know that this forces this triangle to be isosceles, and specifically the sides across from those angles will be congruent. And so if you know the two sides are congruent, you know the base angles are congruent. If you know the angles are congruent, you know the sides are congruent. This is pretty powerful stuff, because now we can turn this into knowledge about particular geometric figures, like this one. In triangle DEF, side DE is congruent to side DF, and those are marked. And then it asks us to name two congruent angles. Well, this is like the first time that we've talked about how if you know something about sides, you can know something about angles. Specifically, this is an isosceles triangle. And the isosceles, or rather the base angles theorem, tells us that if a triangle is isosceles, then the base angles are congruent. And so the base angles are the ones that are across from these congruent sides. So that angle there is congruent to that angle there. And we can say angle EFD is congruent to angle FED. And there you go. Now you could also call these angle F and angle E. Okay? So that's what the theorem does for us. We know something about sides, we instantly know something about angles. So let's turn this heat up just a little bit. Again, we have DEF. We know that DE is congruent to DF. In other words, this is an isosceles triangle. Now we want to find X. Well, in all isosceles triangles, the base angles are congruent, which means that this angle here is congruent to that angle there. Well, what does congruent mean? It means the same measure. And so if F is 75 degrees, X is also 75 degrees. And we're done. This is how a theorem can tell us how to solve a problem. So here we go with another one. In DEF, DE is congruent to DF Find the length of DF. Again, we have an isosceles triangle. In an isosceles triangle, the sides that are marked are congruent to one another. If DE is 27, then DF is also 27. Now, it's not degrees because it's not an angle, but there you have it. Understanding how to do those kinds of problems helps us do things that are a little bit more complicated. Here we have a triangle that's a right triangle, but it also has two angles that are congruent. And the base angles converse theorem tells us if two angles of any triangle are congruent, then the triangle is isosceles, which means that what we know is that this side is congruent to that side, right? So if that's true, and we want to find the value of x, we're going to need an equation. But isn't 3x plus 2 equal to 24? Isn't 3 times x plus 2 equal to 24? That's what those markings mean. And so now we have a solvable equation. And the first thing to do is to distribute that 3. So we have 3x plus 6 equals 24. And then subtracting 6 from both sides gives us 3x equals 18. Gosh, I hope so. Dividing both sides by 3 gives us x equals 3, and we're done. Again, in order to get to solve for x, we need an equation. In order to understand how to set up the equation, you have to understand the theorem. The theorem tells us if there's two angles in any triangle congruent, then the triangle is isosceles, and the sides across from those angles are going to be congruent. If they're congruent, they have the same measure. If they have the same measure, then they're equal, and there's your equation. All right, so let's do another one, slightly more complicated. I think this is probably a homework problem, so this one will be good to do together. Find the values of x and y in the diagram. So the first thing we want to recognize is that we have a right triangle here. We also have an isosceles triangle here, and we have what appears to be a scalene triangle here. And so we're going to have to use a few tools in order to figure this problem out. And this is kind of complicated, but it's okay. We've got all the tools in the toolbox. The tools in the toolbox are our theorems and our postulates. So what we know about isosceles triangles, that's an isosceles triangle right there. See how the sides are marked? That the base angles are congruent. In other words, this angle here is going to be congruent to that angle there. And so if that one angle is x, then so is that one, correct? The other thing we know about all triangles is that all three angles have to add to 180. And so far, we could take whatever x is, add it to whatever x is, and then add it to some other angle. Let's call it angle dot for now. Then that's going to equal 180, correct? Well, sure would be nice to be able to fill in a number for that dot. So how do we do that? Well, let's take a look at this angle, this dot angle. Do you see how it's part of a linear pair? Do you see how those two angles share a vertex and a side, and their non-common side makes a line? If this one here is 40, and all linear pairs are supplementary by the linear pair postulate, then doesn't this dot angle, doesn't this dot angle, oh, it won't let me erase, there it goes, have to be 140 degrees, right? Those two have to add to 180, and now we can use our theorem and our logic to replace dot with 140. And now we can solve this equation, because x plus x is 2x, plus 140 equals 180. Subtracting 140 from both sides gives us, subtract 140 gives us 2x equals 40, correct? And then dividing by 2 on both sides, x equals 20. So we know, let me get rid of a bunch of stuff here, that x equals 20, which is awesome because it's a part of this triangle here, which is a right triangle. X equals 20, that's 90, and so we're going to have to figure out what y is. Well, since it's part of a triangle, we know that the angle, the measure of, let's call this ABC again so that we're real clear about what we're talking about. We know that the measure of angle A plus the measure of angle B plus the measure of angle C is 180, right? Because that's what the triangle sum theorem tells us. So the measure of angle A is definitely 90 because that's what that box means. We're not sure what the measure of angle B is, but we want to know. We do know the measure of angle C because we just figured it out is 20, and that's all going to equal 180 degrees. So let's see, 90 plus 20 is 110, plus y equals 180. And then let's subtract 110 from both sides. It gives us y equals 70 degrees. Which makes sense, doesn't it? Because if all three add to 180 and this one's already 90, then these two, this one and that one, have to add to 90. So we know we're right. This is the hardest part about geometry. It's taking all those tools in your toolbox, the triangle sum theorem, the linear pair theorem, the isosceles triangle theorems, and pulling the right one out at the right time, which is why it's so vital to practice, because the more you do it, the more you see it. This is a pretty complicated problem that takes pieces from everywhere, and the hardest type of human thinking is called synthesis, and that's what we have to do on these kind of problems. But it's exactly why we teach you geometry, because synthesis, this is how you learn how to do it. So when you get out in the world, you might not have to solve for any triangle measures, but you will have to take information from here and there and another place and bring it together to solve a problem. This is good practice for that. It gets complicated out there sometimes, and having the practice in a safe place with working with numbers and angles and learning how to synthesize your thoughts is a great way to get better at that kind of thing. Alrighty. Okay, enough preaching, Miss Waite. Your practice is on Big Ideas Math. It's called the Base Angles Theorem. Have fun with it. Do let me know if you need some help. And whatever you do, enjoy. Bye.